Hello, everybody. My name is Lee Fox. I am one of the developers, one of the builders on the RhythmCloud project for the Builders Fair at reInvent. I am joined by Ryan Vanderwerf, who will be talking about our demo later. And I wanted to tell you about our Builders Fair project, RhythmCloud. It is a cloud-powered learning system to learn how to play the drums, and it was really fun to work on, and it's an honor to be able to share that with you. So today we're going to talk about the project history a little bit, just some general details of the project. I'll share the architecture with you, and then we'll go into an actual demo of the system. Before I do that, though, I would very much like to give a shout out to all of the members who helped us with this project. First of all, there's Ryan and myself who really ideated the project and did a lot of the hardware builds. We have Gandhi Swaminathan. Sorry about that. Gandhi Swaminathan, who led up our data analytics portion. Gregor Richardson, he helped us with our UI. Andrew Glenn was a Python coding expert, and John Poole was a very, very lucky add we had to the project. He is an actual drummer, and he gave us a lot of expert information that we needed. Now, the project itself started a couple of years ago. I had one of my children looking to learn to play instruments, and I got involved in drums while he was starting to learn how to play keyboards. And I thought to myself as I was talking to my instructor Les Fisher that it would be really cool to have an automated way to do this. Can we embrace technology to learn how to play the drums? And that's where RhythmCloud 1.0 got launched last year at reInvent. It was a system where we used IoT and Greengrass to light up LEDs on each of the drums to tell a drummer, a student, when you were supposed to hit the drums. And then they would hit the drums, and we would be able to register that through sensors on the drums, and we can analyze it. It was a great idea, but it didn't quite work as great as it could have. So as I was thinking back to my drum lessons with Les, they kind of went like this. He would play something, then I would play something, and then he would yell at me for it. And then he would play something else, and I would play something else, and then he would yell at me for it. But it wasn't quite the most user-friendly thing with that yelling, so I decided to add robotics to this, and Ryan was really helpful in making this happen in this next evolution for RhythmCloud 2.0, where we are featuring robotics. So the learning path now is the robot plays something, you play something, and you don't get yelled at for it. You just get your results, and you can practice and iterate over time. There were a lot of key technologies that we used on the AWS infrastructure that allowed us to make this happen. AWS IoT Core, AWS IoT Greengrass, and AWS API Gateway are some of the key technologies in here. But we also supplemented it with Amazon DynamoDB and Amazon TimeStream for our data persistence needs. A lot of the processing and ingestion of data came in through AWS Lambda and Amazon Kinesis Data Analytics. Finally, we ended up using S3 or Amazon Simple Storage Service for the persistence of all the songs and the definitions of songs that we needed. And we are able to quickly rebuild this time and time again through the use of AWS CloudFormation. Our architecture looks something like this. We have, as you can see, there's a Raspberry Pi 4 that is key to the system. It is actually attached to the physical acoustic drums. And on the Raspberry Pi 4, we are using AWS Greengrass. AWS IoT Greengrass to run Greengrass Lambdas. The Lambdas control two major sets of functionalities. The first set of functionality is controlling the lights and the robotics actuators that move the drumsticks and signal the lights to play the drums. The other The other greengrass lambda is meant to read all the data from the piezo sensors that we have on the drums and take all that information back to the AWS cloud via MQTT messages. There, it's ingested with AWS Kinesis Data Analytics, and we do the analysis on the data, and we present out a score at the end. Now, all of this is great, but there's no user interface on the drums. So we have a serverless web app that we have written using S3 to serve out data, CloudFront, and API Gateway to backend into AWS Lambda functions in order to provide a user interface for the users to start the drums, play the drums, and get their scores back. Let's go and take a look at the drums in action right now and see them going. We'll also learn a little bit more about the technical components within it.
Hi, I'm Ryan Vanderwerf, and I'll be walking you through the RhythmCloud 2.0 drum learning system. What we have here is a drum system outfitted with lights, robotics, and piezo sensors. And I'll be walking you through how all of these things work. Here's the brains of the RhythmCloud drum learning system. This is a Raspberry Pi 4. We have two boards connected to it. We have a breakout board and an ADC board. The breakout board is there so that we can get enough GPIO pins to connect both our ADC board and our light control. So what happens here is when you play a song, we're going to parse a MIDI or YAML file. We're going to blink the lights to the song so um, you know when to hit things. And those are series lights connected all together in the drums with WS2801 lights that can be controlled individually. And after that, what happens is the data is sent to IoT Core as two different topics. So the first topic is the reference data, which is what you're supposed to be doing. And then our second board sends our user data. So this board hanging off the bottom here is connected to all the piezo sensors inside of the drums. It's got 8 channels. It's an 8-channel ADC board. And what happens is um, when it's your turn to play and you hit the drums, it converts that to a voltage value that is then sent to IoT topic called user. And it does that for each drum. So when you're done playing, all of that data goes through IoT Core, gets processed by IoT rules, which then goes into TimeStream database. And our friend Gandhi here has made an analytics engine off of TimeStream that will score your data. So it will run an algorithm to compare what you were supposed to do versus what you did and give you a score in the user interface. The idea behind all of this is you get better over time. So you can iterate over and over a drum loop or a song and increase your score over time, and you will become a better drummer in the long term. Okay, what we're looking at here is one of the drum modules. We have this same configuration replicated 8 times. And what we have here is we have an ESP32S microcontroller, and it has a connection to an L298N motor driver board. And what this driver board is doing is it is controlling car door lock actuators because they move quickly enough versus a regular servo, which moves too slowly. And so what this driver board is doing is has something called an H bridge. And what it does is it basically turns on each uh, door lock actuator to be on or off, and it can basically reverse the voltage to change their direction. And the reason why we have two sticks here is that in order to play quickly enough to over 200 beats per minute, one of the sticks and motors has to be resetting while the other one is firing. And so you can see the connections off the board here. We've got basically two control connections where it's flipping the voltage back and forth on each door lock actuator, and then a control board connection to the ESP32. So the ESP32 is telling it what to do. On top of that, we've got a USB serial connection. That's going back to a sort of a multiplexer hub to the Raspberry Pi. And the Raspberry Pi is sending serial commands to each one of these units. And the serial command is basically a single byte serial command that says, okay, fire this motor or that motor. And what we do is map that in our software to tell which drum to fire when. And we actually had to write a program that probes each one of these boards, and each board will identify, based on the software we wrote and put on them, which drum it is. So when we map them, we say, okay, this is now the crash cymbal or the ride cymbal or the snare drum or whatnot. So at that point, it doesn't matter where we plug them into on USB ports. When we fire up our Pi to run our software, it can figure out which drum is where, so it knows how to control and fire them. All right, what we've got here is our drum rig that is got two card lock actuators and a ESP32 board. So initially when we built this, we tried to use regular servos, like hobby servos, and they just couldn't move quickly enough to hit a drum at the speed that a player would actually hit it. So we came across an Instructables project by a fellow named Randy. He doesn't list his last name, but he had come up with this idea of using car door lock actuators. And so we've he inspired us to do the same design, and we're actually able to reuse some of these wooden templates. We had these professionally laser cut so they look nice, and they're mounted to the side rig. And then those are being driven by the ESP32S board. And the reason why we picked the ESP32 is AWS customers commonly use the ESP32 with free RTOS on a lot of their projects that they're doing. So it's very inexpensive. You can buy a bag of 5 of them for 20 some dollars. And the driver board is also very expensive. $15 gets you an entire box of them. So we can inexpensively replicate this across 8 drums for very little money if you want to build this yourself. Here we have the RhythmCloud 2.0 drum learning system UI. Let me show you around a little bit. We can do two things from our screen. We can upload a song. It can be in either MIDI or YAML format. Go ahead and look at our builder's guide to see what the format is for making your own YAML file. We've already got some pre-done here. So the first thing you want to do is adjust the tempo. So if you're just starting out, you want to start probably with a slower tempo so you can get the hang of it. We're going to crank this way up just to give Lee a hard time. And then we pick duration. So how long of a part of a song or drum loop do you want to practice? So we just leave the default 30 seconds. We're going to put in our stage name. So let's call ourselves Cool Drummer because that's what we want to be. And then we go ahead and pick a song. So I'm going to pick a simple drum roll here. And when I hit play, it's going to count down for the duration that we picked. And the robot's going to play and then stop. And then we'll pick it up from there. Okay, now we heard the robot play. Now we're ready to give Lee a turn here and try to play the drum roll and see how well he does. So just click My Turn. This appears after it's done playing. And click that, and then it'll record everything, and then we'll see how he did. All right, now let's see how Lee did. So after you're done recording, you're going to get a new menu choice here called View Results. If we just click that, it's going to show us what our score is here. So it tells us our score was 75, and we got 75% correct. So I would say that's pretty good. But Basically, what you're going to do is keep iterating and try to get your score up, and your drumming should improve going forward.
So it's been a very, very fun project to work on, but it was absolutely full of a lot of challenges. Right from the start, one of the things that we had to figure out was how to find the right mechanism to swing a drumstick. As it turns out, there's science and math that goes behind it. Drumsticks have a weight, you swing them with a certain velocity, you have to calculate force, newtons, and such. And then we had to tie that back to find the right device. Originally, we started off by using hobby-style servos, but we've moved to car door lock actuators, moving the drumsticks on a pivot, which worked a lot better. And then once we had those devices there was still a lot of math that went into it to figure out how we were going to coordinate the timing of all the drumsticks to move in time. And that was the one thing that we could not skip in this project. We had to have absolutely great timing. When you play a song, there's a certain tempo that goes with it. 60 beats a minute, 90, 132 beats a minute. And if you don't keep up with that right tempo, then your song just doesn't sound right. So we had to learn how to calculate the amount of time that was necessary between each of the drum hits and react accordingly to the drum play. The drum data analytics was another very, very difficult portion. I mean, if you think about it, we've got a robot that's playing, and it can play a very, very repetitive and consistent style again and again. But the user, being human, does not have that ability. So to take those two sections of drum play and overlay them so we can see just how accurate the user is, that was very, very difficult. We did find within our friend Gandhi an expert in data analytics to help us out with that. We were also plagued throughout all of this in terms of the building of the drum system. There was a lot of components that needed to be built from scratch, and solders, all the wiring that needed to be done. Sometimes the wiring went bad, and it was hard to actually debug what was going on with that. If the best example of this was when we first started playing TNT on the drum kit for the very first time. It looked amazing, but the drums almost shook themselves apart from all the vibration in the play, and it caused some bad wiring to happen, some shorts. Debugging that was very, very difficult. Finally, the last two items that we have here for project challenges really come down to the code that we had to write. We had to learn how to write code for the embedded microcontroller programming that we did, and alongside of that, we had to figure out the best and easiest ways to debug the code when there were issues in it. We did pull in some help with our friend Andrew Glenn, and it was a great learning experience for us. But with all of this, we had a blast. It was a great technical challenge, and Ryan and I both hope that we are inspiring everybody to do builds of your own. We do have this information available for download if you'd like to get to our build instructions and build these yourselves. Thank you very much. On behalf of my colleague Ryan and myself and the rest of our team, thank you for your interest in the RhythmCloud project.